Hello guys and welcome back to the second part of our video tutorial series on multi-threading. So on our last video on multi-threading, there we have understood in detail that what is a multi-threading, what is the actual reason of implementing a multi-threaded application, and what is the different type of way of creating a multi-threaded application in Java. And in this video, we will be covering one of the essential and the crucial topic for multi-threading, and that is the concurrency control. So if you have not gone through my first video on multi-threading, I will highly recommend you to go through that video first and then come back to this video, because this will be a continuation of the previous video. Hi, my name is Anindo and welcome back to my channel. So without wasting much time, let's start with this video and let's understand that how we should do the concurrency control within our multi-threaded application. So let's start with this video. So if you have remembered in our last tutorial on multi-threading, there we have implemented a restaurant application for the demonstration purpose. And over there, if you had remembered, while following the output of the program, we have found one issue. And that was two or more threads were entering the critical section of our code, and that is the keychain together. But the actual problem was, in our restaurant there was only a single oven, and the single oven can only be used by a particular user at a particular time. But here in the output you can see two threads have started processing the critical section of our code together, which is actually violating the problem statement that we want to achieve. So let's see how we can solve this problem of blocking a particular thread when some other thread is working on the critical section of our code. So as we have seen, with the simple implementation of the multi-threading, though we have a single critical section, but multiple threads was accessing the critical section simultaneously. So over here in this problem statement, we need someone to block two threads to enter within our keychain. And for that we need an additional helper, which is nothing but called as a monitor. So according to this example, monitor is nothing but a single person who will continuously check that whether the critical section, that is the oven, is being used by any threads or not. And if the critical section is not blocked by any thread, only then he will let another thread to enter the critical section. So basically we can solve this problem of concurrency control with the help of a monitor in our program. So let's see how we can implement a monitoring approach and implement a monitor within a code. So let's further modify this code so that we can actually solve the purpose which we are looking for. So the way we can apply a monitor into a Java block of code in multi-threading is with the help of a single keyword, and that is synchronized. And with the help of this synchronized keyword in multi-threading, we can actually handle the concurrency control within our program. So there are different ways of implementing a synchronized code within Java. So let's see one by one. So first thing first, we have to see that which is the actual critical section of the code. So if you see, the critical section of our code which we have written is preparation of food, because this part of the code is actually dealing with the oven, which is the only resource we have in our kitchen. So this is actually a single piece of code which needs to be protected from multiple threads. And the first approach of placing a monitor in the code is by using the synchronized keyword on the method level. So since this is the critical section, so over here in this line, if I just put the keyword that is synchronized, then this synchronized keyword will act as a monitor for this entire method, which means that until and unless a particular thread have not completed this entire line of code sequentially, another thread cannot enter this block at that time. So let's run this code so that it will be helpful for you to understand that what I'm actually want to say. So let's run the code. So here if I go to the output of this program, here you can see the thread 1, that is the thread 0, have taken the order, started preparation of the food, and once the food was being prepared, thread 2 might be taking the order. And also here thread 3 have also taken the order. But none of them started with the preparation of the food until and unless the thread have completed the preparation of the food. So here you can see that until this start and the corresponding done is not being completed by a particular thread, another thread have not started preparing the food, which means that the critical section of the code was handled by a single thread on runtime. So I hope this makes sense that how we are controlling the concurrency control over here. So to make this example much more clearer, let me put our meaningful sysout over here. And let's run it again. And great, we are done with the program, and let's now analyze the program one step at a time. So here you can see the thread 0 have taken the order and started with the preparation of the food. And while he was preparing the food, at that time obviously the kitchen was busy, which means our critical section was occupied. And at that time our monitor, that is the synchronized keyword, was acting as a gatekeeper so that no other thread can enter and access the critical section of our code. And here you can see at the time when thread 1 and thread 2 were blocked by the monitor, they were just simply taking the order. And once the thread 0, that is the first thread, have completed the preparation of the food, after that only thread 2 have entered the critical section of our code. Similarly, until and unless thread 2 is not done over here, our monitor have blocked thread 1 to go inside, and once the thread 2 is done with the preparation of the food, at that time only thread 1 could enter the critical section. So here you can see how with the help of a simple keyword that is synchronized, we have prevented the concurrency control over here. So during the technical interview, if the interviewer asks you that how would you implement a concurrency control in a multi-threaded application, then this is the answer to your question, that we will be placing a synchronized block within our code. Now since we have understand that how powerful this synchronized keyword is, let me show you some other different way of implementing the synchronized keyword. So the another popular way of implementing the synchronized keyword is by creating a synchronized block of code. So here if you see, since we know that this part of the code is our critical section, we have made this entire method as synchronized. But rather than that, we can also make a particular segment of the code as synchronized. So for example, if I put another sysout over here, and this time we will not provide the synchronized keyword at the method level, rather we will do on a block level. So what we'll do, since this is the critical section of the code, we will provide the synchronized keyword over here. So right now this part of the code is only synchronized, which means that though this entire method is the critical section of the code, but we are allowing the thread to enter the kitchen but not to access the oven. Which means that with this approach, the thread can enter the kitchen, but he cannot start preparing the food until and unless the food is being prepared by the previous thread. So I hope you understand that what I am trying to implement over here. But if you notice carefully, this block of code is giving a particular error, and that is this synchronized keyword is looking for an argument over here. So let's see what is the argument that we have to pass over here to make this block synchronized. And the argument that we have to pass on a synchronized block of code is a type of object, which means that we have to pass any object that is being shared by all across the thread. So it can be any object that are available on Java. So let's create a log of object type string. So if you want, you can put any name over here. And within this synchronized block, we have to just pass this log object over here. So we also have to make this as static. And that's it. So right now what is happening is this block of code is logged by a single key, which is nothing but a specific object of the class which both the threads will be sharing. So here you can see, since the log object will be shared by both the threads, so here with the help of the log object we can make this block of code as synchronized. So let's run this program again. So here you can see the answer is pretty similar. So here you can see the thread 1 have taken the order and also thread 2 have taken the order. Then both of them entered the kitchen, but only one thread start preparing the food, and that is thread 0. And once this thread 0 was preparing the order, no other thread was preparing the food at that time. Rather at that time thread 2 have taken the order and also waited in the kitchen. And once thread 0 is done with preparation of the order, thereafter only thread 2 has started preparing the food. Similarly, after thread 2 is done, thread 1 have started preparing the food. And thus in this way there is a synchronized way by which the threads are now accessing the critical section of the code one at a time. So I hope this is clear that how we can make our code synchronized and how beautifully with the help of a single monitor we can implement the concurrency control within our code. So now since we are clear with some basic concepts of multithreading, let's now see how we can optimize this code. So over here you can see there are a lot of code that I have written. So over here you can see there is a specific kitchen class that I have created for implementing a thread. Similarly over here I have created the object and I call the thread one at a time. So there are a lot of codes that are involved over here. So let's optimize this just by changing few lines of code. So let's see how we will do it. So over here first we will create an object of runnable class. So let's create a runnable class over here. And within this runnable class, we will simply call the run method over here. So we'll copy paste the same code from here to here. and we'll get rid of this entire class from here. So let's comment this out. So right now you can see within the main method only we have created an object of the runnable class, and with the help of this we will be implementing the thread over here. So let's see how we will do it. So here we will comment out this part of the code also, and here we will create two threads. Let's create first thread. And if you have remembered from my previous video, within the thread class we have to pass an object of the runnable interface. So let's pass the runnable object over here. Similarly, I will create one more thread. So here you can see with the help of simple approach, we have created two threads within our application. And to start these two threads together, we just have to type t1.start. Similarly, we will be starting the second thread like t2.start. And that's it. With the simple line of code, we have implemented all the things that we have learned till now. Now the only thing that we have to initialize is we have to provide a lock within this main class. So let's initialize a lock over here. And that's it. We are done with the complete implementation of this restaurant application with these simple lines of code. So let's run it and let's see how it is working. So here you can see the output will be pretty similar. So you can see how with this approach and with the help of simple implementation, not only we have implemented the entire concept of restaurant, rather we have learned many things on multithreading, like how to create a multi-thread application, how should we implement a concurrency control, what are the different way and optimized way of creating the threads in our application, and many things. Now since we are done with some basic of the multi-thread application, let's now move to an advanced topic, and that is the interthreat communication. So let's assume the scenario that your restaurant is super popular right now at your location, and thus you have decided that you want to expand your business a bit more, and that is why you have also provided some additional services for the customer, and that is you have placed a live Momo counter within your restaurant. And this time the restaurant is not only giving a takeaway service, but also they have provided a sitting arrangement within the restaurant. So now since you are in this situation, you have to understand one simple thing, that the Momo counter will only produce Momo whenever there is a requirement from the customer. So basically over here the Momo counter is your producer and the customer is nothing but your consumer. So there should be a link between a producer and the consumer, so that there should be a synchronization between the two. Otherwise what will happen, the Momo counter will keep on producing Momo without checking that whether there is any requirement for further Momos or not. Similarly, a consumer have to wait until the Momo has been prepared by the producer. So this problem is more popularly known as the producer-consumer problem, which is one of the most popular and commonly asked questions for technical interview, that design a program that will solve the producer-consumer problem. So in our next video on multithreading, over there we will solve this producer-consumer problem, and we will see how we can communicate between these two threads, that is the producer thread and the consumer thread, so that both of them are in sync with together. So if you want to know how we will achieve the intercommunication between the two threads, do not forget to subscribe to my channel and hit the bell icon so that you will get the notification as soon as I upload this video. So without wasting much time, do like this video and share with this friend. And if you are new to my channel, do not forget to subscribe and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's see you on our next video. Thank you.